Okay, here we are, back again, our interior decorators here, excellent, okay? Now, we want to talk very briefly about meiosis. Meiosis is meiosis like mitosis?
No.
What's mitosis?
Meiosis is like the process in which
She sounds like a textbook. Textbook alert. The process by which identical cells are formed from a parent. Fair enough? You're the one that said it. It's essentially right? They're called, what kind of cells are they called?
Somatics.
Muscle cells, skin cells. All those cells have subtle differences. Some may have more mitochondria. Some may have more diversified organelles. Who knows, okay? But what are cells that undergo a meiosis? What are they called? What are they called? Now, what are the cells called? Reproductive cells. Reproductive cells. That's what they're called, correct? Yes or no?
Yes.
They're called reproductive cells. Yes? Okay, good. Now, how many stages are there to meiosis? 2 stages. Okay, good. We're getting it. This is good. What would the first stage be called?
Meiosis 1.
Makes sense. Meiosis 1. Okay? What happens in meiosis 1? Does anybody know? No idea? No. He's looking right at his book, but he has no idea. That's okay. That's okay. Okay. You okay.
Sir, the chromosome number is reduced.
What is it?
The chromosome number is reduced.
What is it?
Okay, the chromosome number is reduced.
The chromosome number is reduced. Is that what happens?
Yes.
What happens? Anybody want to tell me?
I did. The chromosome number is reduced.
Excuse me. Okay. All right, here's the book. Just to show you that it's in the book, it says meiosis involves 2 cell divisions that reproduce 4 haploid cells. During the first division, called meiosis 1, homologous chromosomes move to opposite poles of the dividing cell. During this division, a diploid cell. What's diploid mean? What's diploid mean?
46 chromosomes.
Yeah, well, for humans it's 46, meaning diploid it has the full complement. 2N means N is the number of chromosomes in a haploid cell. Okay. So, in the second phase of meiosis, the chromosomes are actually divided. Okay? So, in meiosis 1, what does meiosis 1 do? What does meiosis 1 do?
The chromosome divides.
It does what?
It divides the chromosomes.
It divides the chromosomes? It rearranges cell so that C for chromosomes, so that chromosomes what? What does it say? It's rearranging. It's not, there's no cutting or anything. What is it doing? It's rearranging what? The chromosomes. How? What does it say?
Homologous.
All right, let's see. Okay. All right, let's see. Yeah, it's right here in the book, guys. It says, during the first division, called meiosis 1, homologous chromosomes move to opposite poles of the dividing cell. Isn't that what it says?
Yes.
Homologous chromosomes. How do you spell homologous?
H-O.
H-O-M-O-L-O-G-O-U-S. I'll buy a vowel. I'll buy an O. Is there an O in that? Yes. Okay. Homologous chromosomes. What's a homologous chromosome, do you think? What does that mean, homologous chromosome? What does that mean?
Of the same trait.
What's homologous chromosome? Look it up in the back of the acronym. Homologous chromosomes.
Carry genes that code for the same trait.
Homologous chromosome. You're lining up homologous chromosomes on either side. What does it mean? We'll do another off camera.
Homologous chromosomes are pairs that one of them comes from one mother and one of them comes from
Homologous chromosome. It doesn't have it in the back. What does it say? Homologous chromosome. Where does it say? Right there?
Figure 1.
Okay? Okay, here it is, guys. You guys, this is one of the reasons. You ready? It says right here, homologous Oh my God, can you do that? It's unbroken. Homologous chromosomes carry genes that code for the same traits in the same position on the chromosome. One of these chromosomes came from the mother, the other from the father. Okay? You guys should have said that. Why? Because look, it's a picture. What's so significant about that? Look, I'm going to put it right on the camera here. You ready? Can you see it? Right there. Okay. You see that?
Yes.
You can put that on pause. You see that? But why is that so important? Because when you read the book for the first or second time, you're looking at pictures, aren't you? You're not reading. Do you get it now? Do you get it now? You get it now? You guys read the chapter, didn't you? How many of you read the chapter or parts of it? Raise your hand. How many people actually read and looked at the pictures and the captions? Nobody. One person. That's the most important thing. You do that first. Did you ever look at the pictures? Oh, I read the book. I looked at the pictures. Well, in science, that's not a bad thing. It's a good thing. So you should. It's okay. Your book's fine. So you look at the pictures. That picture, you should have said, homologous chromosome. I know what that is. It's a picture, right? Homologous chromosome. It was right there. I was waiting for somebody to see it. Okay. Now, so they rearrange the cells so that the chromosomes are on either side, right? Yes? And so then then what's meiosis 2? What's meiosis 2? Say what? What does it say? The chromosomes divide. All right, and 2, we have the actual division. What's the difference between, sounds like mitosis.
It has 2 stages.
What is it?
It has only
It's
2
like
stages.
It has only 2 stages, but what?
In meiosis 1, the 2 chromosomes, they go through, they exchange their pieces of genetic information. So that a completely new.
Okay, all right. What's going on here? This is I see part of the problem. You're not looking down. You're just reading the surface. Okay, if you're just reading the surface, it says during the first cell division, called meiosis 1, homologous chromosomes move to opposite poles of the dividing cell. You can see it. I'll show you the picture in a moment. Okay, and then during this division, a diploid cell becomes 2 haploid cells. So in this first part, is there an internal division happening? Yes. It says, look, it says right here. It says, during the first division, called meiosis, homologous chromosomes move to opposite poles of the dividing cell. During this division, a diploid cell becomes 2 haploid cells. You get it? Now let's look at the picture. Okay? So, you have can you see it? I'm having a hard time holding it up here. There it is. Is that it? Is that one? Okay, so it says figure 2. Let's look at figure 2. Okay, figure 2. It says the process of meiosis requires 2 cells, 2 cell divisions. During the first division, the chromosome number is reduced, right?
Yes.
During the second division, the chromosomes divide and move to opposite poles. So is there actually, maybe I kind of misspoke a little bit, is there actually a division, of the chromosomes in meiosis 1? All right, you see that? And the answer is yes. What happens is you get one from each parent, don't you?
Yes.
You get one from each parent. Okay? A whole chromosome. Homologous chromosomes, right? You get one from each parent. Okay? And then what happens is this. I'm having a hard time holding this up. So then you get one from each parent, one gold, one blue. Okay? And then, now in meiosis 2, now those develop, what's the problem? Those develop into four cells each. You see that? So you get 4 pairs at the end. 1 female, 1 male. You see that?
Yes.
Yeah.
You get it?
We see that.
Okay, good. That's meiosis.
Okay.
Good? Yeah. Just let me ask you a question. What did I do differently than what you should be doing?
Explain that.
Yeah, I explained, but I didn't really explain anything. I just looked at the pictures. I just reworded things. You've got to fight this. What, you don't just read it and say, okay, I'll move on. But what does it mean? I don't get it. I still don't get it. And you will get it. And if you still don't get it, what do? You write it down, you say, you come into class and you say, nah, I don't get it. Okay? And we'll go through it. I have no problem with that. But what did I do? I went through that as if I didn't get it either. And then you eventually get it, right? So the first division here is where you're separating, so you have 2 diploid cells. 2 diploids, right? Yes? A mother diploid and a father diploid. Yes?
Yes.
Haploid. That's deep.
No, diploid.
Diploid.
Diploid. Diploid.
Diploid.
You get diploid. You see that? Right here. They're lining up. Here they're all random. Now here they're lining up. Here's the division. I have 2 diploid. I have a diploid mother and a diploid father. And now I have two separate cells. Each are diploid. Oh, that's diploid. Okay? And then I take the 2 diploid cells. Okay?
Diploid cells have 46 chromosomes.
Yeah, but no. But look, but these are 2 diploid. That's a diploid and that's a diploid. They have 2 diploid cells each. See that? 2 diploid chromosomes. See that?
Yeah.
That's a full thing, right? And then it switches, and then you get. What's the problem?
And then it reduces into half.
You get it?
Yeah.
Okay. All right. You guys throwing pencils at me because time's up? Okay. All right. So. Is time up?
Yeah, it's 10. Break 10 now.
All right. So. Why are you still here? Okay, wait, hold it. All right, so you've got to do the next thing. We didn't get to it today, but it is. No. We're not going to do 7-3. We're not going to do 7-4. We're not going to do 7-5. We're going to do 7-6 and 7-7. No 7-6 and 7-7. That's KNOW. 7-6 and 7-7. Skip the other section. Is that clear?
Yes.
Have a good one.